let's talk a bit about what happened in Kokkos-Core. So I assume that all of you are aware, right? In Kokkos-Core, we've been, for a long time now on release cycle where we say like we do fixed releases, right? As fixed release times. We are not trying to strive for like, here is the big new feature release, right? It's more like whatever is ready, is ready. So we've been operating very much under, under a mode where we are just continuously trying to improve what's going on, right? How the project works, right? That means incremental improvements, right? Like even for like larger feature sets, we are not necessarily, waiting until the whole thing is ready, but we are incrementally merging them in, and so you get certain capabilities, maybe just first for one backend and then later for another backend. That has been shown for us to be a more sustainable way of operating. It also takes away, the kind of pressure to, delay releases because something isn't quite ready or so, and we feel that has been working pretty well for us. One big focus of our work has been and continues to be stability, reliability, and keeping the technical debt in check, right? So we've been doing a lot of work of like hardening our, like the constraints around our APIs, making sure that we catch if somebody misuses them or uses them in ways which it's not intended or isn't, might not be portable across all the different backends, etc. We've been investing quite a bit of resources in keeping, our code base maintainable, overhauling things, reworking things to make them, more in line with like modern design practices, etc. So that is really, one of the big themes, of how we are operating, right? So, even like major releases, right? Other than the update of like the tool chains we use and the removal of deprecated code, right? Don't expect that big new features come only in at like these major releases, right? There is not gonna be a release which comes with one big new feature, right? Almost always you will see that these bigger features come in smaller chunks over time, right? And that's something we found quite a bit more sustainable and robust in terms of how we work.
Okay, so with Kokkos 5.0, so as Christian was saying, that when we bump a major version number, that's when we will bump our requirement for C++. So with Kokkos 5, we require C++ 20. And what comes with it is that obviously, so for instance, some of the older compilers that we had were not able to support that standard. So what we do is we take time at that moment when we are about to bump the C++ minimum requirement to look at develop new minimum requirements. What some people might not be aware of is that this is something that we welcome feedback for. So if you're already, for instance, in the next standard and you have special need, you can approach us in that phase. So the specific version numbers, I don't think they're really interesting. You can find them on our website. So with Kokkos 5, that's the version we have. One thing we didn't mention before, but you might be aware of because we had already done it with Kokkos, the transition from Kokkos 3 to Kokkos 4. We understand that some people might not be fully ready, even though we had said we were going to C++ 20. So what we do is the latest minor version of the 4x, which was 4.7. We commit to support it for a full year. So we released back in July, I think. And so if if you're still on C++17 and haven't migrated to 5.0, you can still report problem, and we will actually in next month we're going to have a patch update for it. So that's how we function. So Christian was talking about the cadence. So it's kind of the train model. We release on time. If you look statistically in the last year, you could see we were about releasing 3 times a year, and if you look carefully, you'll see that we've been a bit more rigorous, and now we're already at a point where we release. So we release in March, we release in July, and in November we're going to work towards having a calendar. But for the major release, so every 3 years, the idea was that we don't want to have the number of C++ standards that we have increase, because the reality is we have finite resource in CI and whatnot, and we can't forever stay on a standard, and then you have less guarantees that we will look at the new version. So you can expect C++23 requirement to happen in 2028.
One more thing on the compiler versions, right? Our intent is that we will support these compiler versions through the 5.x cycle. That is not an absolute hard guarantee, right? If we later find out there is some, compiler bug in some of these tool chains, which is really, really painful to work around for like newer features we are trying to use or implement, then we may renegotiate on that, right? We will reach out to the community and ask if that's a hardship if we increase that compiler version. But the intent is to support those. That said, this does not mean that these minimum versions are the recommended versions, right? Please keep updating your tool chains, right? Like, we are aware of like bugs in some of these tool chains. We work around bugs in our own code, but it might mean that you might need to work around bugs in your code as well, right? And you get other benefits from updating, like better optimization, etc. So minimum is not recommended, right? So just to make that very, very clear to everybody. And if you have your own project, your own library in particular, which then other applications depend on, right? Feel free if you can, right? And you negotiate that with your customers to set your own minimums higher than our minimums, right? That is something, for example, Trillinos does, right? Trillinos is not actually running our minimums. It is potentially going to higher minimums, or has gone to higher minimums on some of these compiler pieces, and that's perfectly fine, right? So we said, C++ minimum standard changed in Kokkos 5. We are leveraging new features internally, and we exposing new features externally. One of the things is modules. This will be on the next slide. One of the big things, right, in C++20 is concepts and constraints. So that actually makes design of interfaces much nicer. I recently gave a talk as part of the Ideas web series. What was it?
HPC Best Practice webinar series.
Okay, HPC Best Practice webinar series. Excellent. You can find that online or ask us on Slack about that. I talked quite a bit about API design with constraints and concepts, and how that can help you write better like overload sets, etc. But that's a really, really cool feature. I think it allows you to get rid of sFine in almost all cases, which makes things look much, much nicer. As Damien already said, right, next increment C++23 will come in Kokkos 6 in 2028. Similar to the compiler versions, right? This doesn't mean that you can't already use C++23. We are testing with C++23 on certain platforms. NVCC doesn't support it yet. We expect that to happen hopefully in the near future. But for example, with ROCm, right, you have a pretty modern LLVM compiler there, and that works perfectly fine with C++23 enabled, right? So, if you can go there, feel free to do so. The modules thing, that was another one of these C++20 capabilities. It's something we are testing. We have that in our CI with Clang 19 upwards. It should work for all the host backends. One of the things it does is, and that's something we tested on, what I saw, for example, on my laptop, is that it does reduce compile time. That was the intent of these modules. Essentially, what they do is they kind of encode like the AST or something in, instead of just header files, and that can, reduce the time for parsing, etc., and thus reduce compile time. And what you do in your code is, right, you now, instead of including header files, you import the module, the C++ module, and then can use that. There's not just the Kokkos-Core module, there's other modules. The core is the primary one, but we have then modules for specific sub-things, kind of reflecting where you had to include specific headers, like, for example, for the container classes. Right now, it requires a fairly modern CMake, and I'm not sure with CMake 4, but in the CMake 3 series at least, you do need the Ninja generator for modules, as it doesn't support the make file.
You should use Ninja anyway, so.
Yeah, it's Damien, he is always using all the things. Maybe everybody does except for me. He always complains about my VI, which is like usually, like vanilla VI, with none of the cool things, all the cool kids have. But, that I'm showing my age.
So, I want to speak a little bit to the snippet. So that's one of the awkward thing with Kokkos modules. There is a bug on that slide, actually. So yeah, the modules are great. You can import Kokkos-Core, but you remember how we ask you to annotate your function? That does not come with the module. So the bug on this slide is you need to include Kokkos macros. We have some documentation, and we're going to increase the visibility of this, but that's one of the awkward thing at the moment with the modules, and there is no other alternative that we know of at the moment.
That said, that code snippet is fine because I don't use any macros.
That's right. Thank you, Christian.
You're welcome. So one big thing in Kokkos 5, right, was the view and MD-span update. So essentially, what that release did is it replaced the entire guts of Kokkos View, right? So essentially, Kokkos View, as you get from Kokkos 5.0, has literally almost zero code lines shared with the Kokkos View from before. It's an entire complete rewrite, and we are pretty happy that we got that done without breaking everything downstream. So that, considering that it's kind of central to what we're doing. What this does is it essentially puts Kokkos View on top of MD-span, or at least on top of the mechanisms in MD-span. It uses our own backport. That MD-span implementation is actually usable without anything else of Kokkos. It's a C++17, C++20 backport. The goal of that was, there's a couple goals there. One is technical debt, right? Some of the implementation of Kokkos View was extremely gnarly. It was, dark corners, right? You better don't look. Another thing is it helps us with interoperability, right? So we had this interoperability talk from Nick earlier this week. And one goal here is that if you design things, you're in the non-Kokkos world, you design things with MD-span, that, now the Kokkos world is much more compatible with that because you can just get MD-spans out of your views, right? And vice versa, right? Create views from MD-spans. Again, in principle, this update should be fully transparent to you, right? There should be no impact from that on your code. Should just work. I hope it, we think it does for most people, as we had some performance issues in 4.7.0, which is why we turned it off again in 4.7.1, and then we fixed them and we turned it back on in 5.0. But we feel that should be ready. And there's these two talks, we had, as the one I already mentioned for the HPC best practices webinar, and then the one from Nick. Both of them talk about, how to use MD-span interop as well.
So if you were turning it off with the advanced option, try it again, and if you have issues, talk to us now on the view things. Okay, so let's get talk a bit more about deprecated code. So together with the major releases, so one thing along the major release cycle, the 4x, we tag things as deprecated as we go. And the major release is the moment where we tell you these things are going to be gone. So we tend to be nice, and we just disable it, and you can still get them for a bit longer. But an important thing is that now we are about to release 5.1, and in 5.2, most of the deprecated code 4 is going to be gone. So if you haven't, if you just turn it on and didn't move, you should probably start worrying a bit more. So if you look at the activity, we're already proceeding to most of the removal. If you have some non-problem, you can reach out. But in 5.3, everything is going to be gone, so that you know. Some notable things that we've done. So, I mean, the makefile support we had been warning for a very long time. This one we did not wait. We removed everything in 5.0. The tasking was a difficult story where, in short, it's something that really never took and was not implemented for some of the newer backend. It wasn't implemented for HEAP nor SQL. We just removed it in 5.0. One of the major things that we've also been talking about for, 4 years now, is that so CUDA UVM, so if you're not familiar with it, it's not about letting you in your code specifically using the shared space and doing migratable. It was an option that was kind of problematic because what it changed the default memory that we would use systematically with Vue. And it would make it was kind of forced UVM. And so we had warned for a long time. If you didn't know about it, you weren't using it, there is no problem. But if you relied on this, we are taking it out. This is the end. And another thing worth noting is we had this experimental OpenMP target backend for a long time. And it never really delivered on what we were hoping, and we decided to remove it. 5.1, the release 5.1, that's going to be probably released next week, we'll have it already gone.
Okay.
You want me to do this one?
Sure, we need to go.
Yeah. No, we have a lot. Yeah. Yes. So a little bit about the lifetime management of object harden. So if you've been using Kokkos, you know that you're supposed to initialize Kokkos and finalize Kokkos when you're done, and you cannot reinitialize Kokkos afterwards. But so you need, it's not just about calling this, all the Kokkos object, like Kokkos views, really any Kokkos object, they can only be constructed until after Kokkos was initialized. And so you probably noticed it with views. If you were holding on to them past Kokkos finalized, you would get some error at the end. But we were generous, and we are in the process to slowly harden these things. So there are things that happen to work, but that are not going to work anymore. For instance, we were really, really diligent. It was actually kind of funny to try to see which parallel for you could call before initialize. But now you can't anymore. We're catching these things. And one thing of note that we're going to cover more in depth in the release briefing for 5.1 is now execution spaces. You cannot construct this guy before Kokkos initialize anymore. If you have more, we're going to cover it more in depth in the release briefing, but the idea was that they were in some sort of invalid state that was really sketchy, and you can't do that anymore. So just like, so it's, you have to construct them after initialize and get rid of them before finalize. And yeah, the other thing is, which hopefully was obvious, this one you would have run into a problem, is you cannot construct an execution space within a parallel region.
Okay. So over the last year, we had some major improvements in a couple of big capabilities. One of them was the graph interface. This is something actually some friends from Belgium worked on pretty hard. They have an application which uses this graph interface. This is, the graph interface is kind of allows you to build like a graph of kernels and submit it. It sits on top of things like CUDA graphs, rock graph, etc. And they've been working pretty hard to make that more usable for themselves. Roman, the student, PhD student who working on that, is really, really great. There's a couple things, right? You can now create a graph object, instead of just having it, being built inside a one contained lambda. You can actually get kind of a naked root node back and then construct it essentially in an unstructured way, right? It comes with some pitfalls if you do that, but you can do it. Interoperability has been improved. For example, you can actually get out like the native graph, also like the CUDA graph handle, for example, or even incorporate a CUDA graph handle into like a Kokkos graph. Multi-GPU support. They added something, which I originally was fairly stringed against, but they wore me down. Capture mode, right? Where you essentially start like saying, okay, I want to capture a graph, and then it just records all the operations you're doing until you stop capturing. It has lots of foot guns, but it can be fairly useful.
Don't use it.
Yeah. All in all, the graph interface, I think, is in a much better shape than it has been. And we did pull it out of, did we pull it out of experimental now? Maybe not. But it is in a pretty decent shape, and it's something where we would like to get more feedback from people, trying to use that and see how it can get them benefits, right? In particular on CUDA or HIP, that's something which could help with situations where you have like lots and lots of kernels, maybe even independent kernels, and you are latency bound on like launch latency, right? That's something where this is intended to help. MD range policy performance, we've been working quite a bit on that. There is actually going to be a talk on that later. I think tomorrow, is it? Or is it today? Yeah, anyway. We had long time issues with that. We actually, I think we got a lot of the issues for the GPU side under control now. Like in particular, for example, for some reason, left and right iterate were performing differently in ways which were hard to understand or explain. I still don't understand why it was performing differently, but with a new implementation, it doesn't anymore. It's sitting on top of the same implementation, and that does much better. We still have to look at the host performance. That's something we want to do. But the goal here is that in canonical cases, right, MD range policy will not perform worse when you rolling your own with range policy or team policy or something like that, right? That should not be the case. If you find examples of that, right, send these examples to us and say, this sucks in this use case, fix this, right? That is the goal here. Generally, right, if you find examples where something in Kokkos doesn't perform as you expect it to, or where you say like, oh, my raw CUDA example or whatnot, or my raw HIP example is better than what you guys are doing, send that to us, right? At a minimum, that is potentially a performance bug on our side, right? at a minimum, we want to know, where we have overheads and potentially document that and say, yes, this is expected for certain reasons, right?
And just about MD range policy, for those who were not there last year, we got hammered on this. We had multiple people report we were too slow. So that's hopefully at least you get this out of this user group meeting. That's a place where you can, if we've managed to ignore your report for a while, you can come on the scene and remind us. Okay, so just other miscellaneous improvement we've been doing. We've been trying to improve a bit our numerics modules. In particular, with 5.1, we finally decided, instead of trickling the last few math functions we hadn't implemented because we thought people wouldn't use them, we decided to just go ahead and implement everything. So with 5.1, you're going to have everything you would have from the C++ library. Another thing worth noting is we had, support for half precision in my function, but underneath the hood, we were just casting to single precision. So, it would compile, but it was not doing what you might think. It was documented, but anyway, we are now on all the major backend actually leveraging the math reduce precision function from the vendor when they're available. So this is another notable improvement if you're doing reduced precision. Another thing worth noting is we added the Brian floating point support for heap, I think we call it B-half-T. And we are planning to continue improve on our numerics and in particular extended support. Another thing worth mentioning, so we had backported the C++20 bit manipulation function from the standard library in previous version of Kokkos, so you could use them even though they were not yet available with standard library. And we decided to keep them because if you use the thing from the standard library, you won't get the best on GPU, you won't get intrinsic, and ours with C++23 in particular, you get the best of both worlds, the context perfing and intrinsic on GPU.
Yeah, there are a couple smaller other improvements, atomic improvements. We fixed a whole bunch of performance issues, where it wasn't actually hitting the right kind of hardware intrinsic for specific combinations of types and operations. Just to give you guys a feel, right, there is about 7,000 distinct atomic operations you can call on a NVIDIA GPU. And making sure that it all hits the right thing, and not go to some fallback isn't completely trivial because it's a 7,000 sparse set of operations. 128-bit atomic native, were actually introduced now. That's something, NVIDIA GPUs added something like that, for example. Another interesting little feature, unrolling. Somebody really, really wanted that and, convinced us to let that in. This is a trait you can put on range policy. It's really only doing anything on CUDA right now, but essentially it allows you to do unrolling inside the range policy kernel, right? That can essentially introduce more instruction parallelism and have more work per thread, and that can help with performance in some cases. We actually use that internally for view initialization and view copy operations now, because those are very, very lightweight kernels. Shared library support in Windows was something some of our customers wanted and was introduced that makes life there potentially easier. And one other interesting thing on the CUDA side is we started using this grid constant attribute, which was not too long ago introduced. It's a while, but that was one of the reasons why we chose 12.2. One of what that does is it essentially eliminates this constant launch mechanism we had before, and that means you don't need, you get more asynchronicity than you had before, which and reduced launch latency on many, many kernels. So that is actually pretty cool and noticeable. There's a bunch of things we're working on. One of them is self-similar interface. This is something where we hope that you will be able to write reusable function you can call both from the host as well as from within, for example, hierarchical parallelism. So you could write a vector add, which you actually can, which has a parallel 4 in it, but you can call both with either an execution space instance, from the host, or with a team handle from within a kernel. That should enable you to write more reusable code. It makes life easier in that sense. And it also means that, you can now, we can eliminate some of these policies which actually kind of mean the same thing but have different names. Like team vector range means use all the parallelism of the team, right, and parallelize this loop. That is actually what range policy says, right? Range policy says take this handle and parallelize this loop with all the parallelization in there, right? This is in the works. There's a PR in for the first piece of that. You will see again, feature extensions of that over next year or so. But I think that's actually pretty cool and a major improvement for the general parallelism API in Kokkos. View API extensions, we are going to move towards that you can essentially use the MD span type parameters. What that, leveraging our rework of the view. What that allows you to do is it allows you to use custom layouts in the future, defined as in an MD span, right? So you just need to read them with C++ standard and implement something which is C++ standard compliant, and that will work with Vue, right? It will allow you to specify index type properly, like switching between 64-bit and 32-bit indexing for your view. It will allow you arbitrary mixing of compile time and runtime extents. And we will likely introduce publicly customization points which allow you to do some type of advanced accessors you couldn't do otherwise. Saccado and Trillinos is leveraging those already. It allows you to do a lot of fairly funky things. One of the things, for example, is that you can decouple your return types, from how you store things. Like you could store now things as a char buffer and still return accessors which do, give you complex double back or something like that, right? Now, is that something you should say yay, finally I can do that. I should rewrite all my stuff to do this. No, you should not, right? This is expert features for difficult situations, right? And best come to us first before you try to do this and ask us for guidance, right? This is not something you should just jump into. Last but not least, Next Silicon backend. That's something coming up. A new backend supporting Next Silicon architecture that's upstreaming starting now. It's a pretty interesting architecture doing, it's a data flow architecture with some pretty interesting software compiler infrastructure around it for online optimization. We can't say too much about it. A lot of that is still under NDA, but the upstreaming will start now. And if any of your institutions work with that, we will see that soon. SIMD overhaul, that has been going on for quite a while. We are trying to align fully with C++26. We're pretty close. We are fixing the usability when enabling CUDA or HIP. That was a big problem. You couldn't actually have AVX2 SIMD types when you enabled CUDA. We're extending. We're going to try and extend the SIMD usage to GPU better. We added an SVE backend, which was contributed by SidePearl, a European company. And why should you care? Auto-vectorization is really problematic, right? I think all of you have struggled with that. SIMD types can work around that. And the other thing is we believe that going forward, exhausting memory bandwidth on GPUs is actually going to be fairly difficult with just scalar memory ops. And so we might actually need to use these SIMD types even for GPU backends to get some more performance out. Okay, that's it. This took longer than I thought, but